Hello, my name is Axel Scherer. I will give you a quick introduction into sequence items in UVM. So sequence items are basically the building blocks for both your constrained random stimulus generation and also the associated coverage collection. You can think of them as the lowest level transaction in your system, right? So the atomic level. But obviously atoms are not enough. You want to have some more complex constructs, and those can be created from sequence items. So you basically can combine multiple sequence items into a sequence. Let's look at a quick generic example. This sequence item has a data field, an address field, and a delay field. And then it might have a bunch of constraints that talk about these particular fields or the interaction of these fields. Okay, so that defines the low-level transaction. And then you can use these sequence items and control them from a sequence to build stimulus that is very interesting. So what type of transaction you want to see, how sparse or how densely you want to space these transactions, and all that good stuff. If we look at sequence items in the context of an interface UVC, you will notice that these are basically the communication vehicle for the interaction between the sequencer and the driver, and the collector and the monitor. Okay, so if you want to drive stimulus into the device, the driver consumes a sequence item from the sequencer and then translates that into low-level signal activity. On the opposing side, the collector listens to the bus and extracts from the signal level activity these transactions in terms of sequence items and then passes it on to the monitor. So let's look at some live example of a sequence item. First of all, let's look at this waveform. Right? This is from the collector we've seen before. Right? The collector has a certain sequence item it extracted. And this base transaction is basically a sequence item. So what you see here is in fact a sequence item. It has these fields and things like this that it extracted from the RTL level. Let's look how this is modeled in terms of code. Okay, as we're dealing with an APB system, we call our sequence item an APB transfer, and we derive it from UVM sequence item. And you saw already it has an address field, a direction field, a data field, and a delay field. And below it, there is some constraints that deal with these fields, right, and limit their value space. For example, the delay can only be 10 or less. So that's basically all the fields here in this very simple sequence item. How can we use this to build more interesting stimulus? We look at sequences that basically combine multiple sequence items, right? So if you look at a sequence item, we have the APB transfer as a parameter to a sequence, right? So this UVM sequence here has a parameter that is called APB transfer. So it deals with sequence items of type APB transfer. Let's look at one particular sequence quickly to show you an example of how multiple sequence items are being constructed into a sequence. This sequence item is very simple. It has two transactions, read after write. So the execution order, we first want to have a write and then followed a read, is being controlled in the sequence. You might have some auxiliary code here and all kinds of constraints to make this happen. But in essence, you see here's two transactions. Basically, one pushes in a write transfer, APB write, and the second one is pushing in a subsequent APB read. And you can also see the start address, the address being written and read from is the same, right? So we're reading from the same field. And there's some other plumbing, but you get the gist. You can find more videos like this either on this YouTube channel or at support.kidins.com at the video library for the Incisive Simulator. Have a great day, thank you very much, and talk to you soon.